Hello again, this is Chemistry 110G, Dunyan Community College, Section 5. I'm Dr. Christensen. And what we're going to do for Chapter 1 is just go over some information that can seem a little difficult at first to students. We're not going to go over Sections 1.1 through 1.3. They're all pretty self-explanatory. You can read the slides. But if you have questions about that material, please let me know. So what I would like you to do is open the PowerPoint slides while you're viewing this video. It'll make things a lot easier. And right now I've got my PowerPoint opened right next to me. And so if you see my eyes cutting back and forth, that's the reason I'm looking at the slides as well. So we're going to start on slide 37 of Chapter 1. And it's on scientific notation and metric prefixes. And the main thing we're going to look at in this section is scientific notation. Scientific notation can seem a little confusing at first, but it really is an easy way to prevent making errors in writing large numbers and small numbers. So on slide 38, there's an example of an exponential notation or scientific notation written for the diameter of a red blood cell. The number is 0.000075. You can see where it would be really, really easy to lose one of those zeros if you were reporting that number. So what we do is move the decimal place in a small number like this to the right. In this case, 1, 2, 3, 4, 5, 6 places to the right, making it 7.5 times 10 to the negative 6. So just rule of thumb to remember, if it's a small number, you're going to move the decimal place to the right, and your exponent is going to be negative, always. And the negative indicates a really, really small number. Okay. Let's see. So for a large number, on slide 40, there's an example of 3.5 times 10 to the fourth, which that's the same thing as 35,000. Let's see, there's a better example. Okay, go to slide 42. This is a lot easier. It's listed as 35,000. That's a really big number, and we're going to be moving a decimal place, but you would say there's no decimal there. Well, every number has a decimal after the last zero. So this should actually, if you were going to write it most correctly, be 35,000.0. The point 0 would be after the last zero. So in this case, we'll move that decimal that's not displayed there to the left, 1, 2, 3, 4 places to the left, therefore making it 3.5 times 10 to the fourth. And you can see the number does not have a negative because it's a very large number. So think small number, negative, large number, positive. And generally we have numbers between 1 and 9.9 as the first number in a scientific notation written number. So 9.9 times 10 to the fourth would be okay, but 10.1 times 10 to the fourth would not be correct. It would be 1.0 times 10 to the third. So hope that's not too confusing, but work some of those problems, see how you convert them, and you need to look at your calculator also is a huge help in this. A lot of cases you can type in the big number, hit scientific notation on your calculator, and it'll convert it to this form. Okay, so there's some problems on slide 44. Work those. If you have questions, let me know. All right, section 1.5 is on measurements and significant figures. I'm not going to grade really harshly on significant figures. It can be a little tricky, but just a couple rules of thumb really quick. Let's see, skip over to slide 56. So numbers that, look at number B on slide 56. Numbers that come after the zeros that come, okay, any number that is non-zero is significant. Zeros are the only numbers that will not be considered significant. On B, you have 0.00730 meters. Okay. The numbers after the decimal place, the 0 before the decimal and the zeros after, are considered insignificant because this number can be written as 7.3 times 10 to the negative 3.